Krause-Wood. She's going to speak on enhancing reproducibility through rigor and transparency, including sex biological variable. Dr. Krause-Wood wears many hats here at Tulane, so we are delighted and grateful that she is able to speak with us today on this very important topic. Some of her many hats include, here at Tulane, Professor of Medicine, Professor of Epidemiology in the School of Public Health and Tropical Medicine, Associate Provost for the Health Sciences, Senior Associate Dean for Faculty Affairs, and Associate Dean for Public Health and Medical Education. And also in the Ochsner system, she is a Senior Scientist in the Center for Health Research. Dr. Krause-Wood is and has been a PI and co-investigator on many federally funded grants, and notably, she is currently the PI and Research Director of the NIH's Building Interdisciplinary Research Careers in Women's Health Career Development Grant. Dr. Krause-Wood has more than 100 publications, including peer-reviewed articles, reports, and book chapters. She is a fellow of the American College of Preventive Medicine and the American Heart Association. She's a diplomat of the American Board of Preventive Medicine as well. Her national leadership positions have included standing member and chair of the NIH Study Section, Health Services Organization and Delivery, and member of the NIH Center for Scientific Review Advisory Council. Last but not least, she is currently the president of the Southern Societies for Clinical Investigation and chair-elect and trustee of the American Board of Preventive Medicine. So as you can tell, Dr. Krause-Wood is extremely busy, so we are so grateful that she is here today to talk to us. Dr. Krause-Wood, I will turn it over to you.
Probably a little more than you all really wanted to hear, but thank you very much. I mean, thank you very much. It's really a pleasure to be here. It's exciting to talk about. I know from a research perspective, probably a little bit of a nerdy side of me, but in talking about enhancing reproducibility through rigor and transparency. This is a very important topic for us as scientific leaders, and those of us who may be earlier in our training, you will emerge as a scientific leader as well, but also in our role as true just scientists conducting research and transforming health by improving the discovery that we're doing and translating this into real world clinical practice. So over this next hour, we're going to talk about a number of different aspects and why we're even focusing on this emphasis on rigor and transparency. Several years ago when this really surfaced, it wasn't something that came out of the blue. I think scientific editors and others have been looking at this concept for some time, and concern was beginning to emerge that perhaps the results of our research were not reproducible, perhaps leading to more failed translation into clinical practice, and raised a lot of awareness of what is happening. So by focusing and emphasizing on rigor and transparency, I believe the NIH hopes that we will be able to exemplify and promote the highest level of scientific integrity, the public accountability and social responsibility, and the conduct of our science, enhance the reproducibility with greater scientific rigor and transparency, not only in what is funded for our research and how we actually do it, but also in the publication of our findings. By emphasizing this and focusing, I think the NIH has already provided, and we're doing the same here at Tulane, is to enhance the training, not only for students, graduate students, as well as our junior faculty, mid-career, and even senior faculty, and to make sure that we are emphasizing many of the areas that have been overlooked in the past, such as sex as a biological variable. Very important things, and we'll go through this a little bit more. Now you wonder, why are we doing this? Is something new? Actually, it's not a new concept. NIH has always expected this. The public has always expected this. If you were to ask a community member, and I've done this in various roles I've had on national committees, what do people think about scientists, or what do they think about doctors? The public in general expects that we are doing highly rigorous and transparent research, that the results will be reproducible. that the doctors are providing the highest quality of care, and that everyone has the credentials and the competence to do what they are supposed to do. We don't want to give them a reason to suspect otherwise. However, a number of articles began to emerge, some of the ones listed here as early as 2011, and up to even currently. These are just only some of them, which began to raise the questions about the reproducibility of the research that was being done in biomedical sciences. One of the authors of these articles had noted that the success rates of new program development had fallen from 28% to 18%. That translates to millions and billions of dollars, by the way, when that happens and you don't have high success rates. Not that you expect 100% success rate, but you do want to do whatever methods you can to improve the success rates by basing your research and the translation of those into more innovative techniques on strong and rigorous science, right? So these are important. A lot of questions began to emerge that, perhaps, in the basic science as well as in the clinical science, and evidence was emerging as well that you were unable to reproduce the results that were published. And this began, of course, to raise a number of questions. If you look at this slide, what it's representing are the major stakeholders in science and the extent of interest in research and its results. This was published in 2014 in PLOS One, but what you see across the top, the vertical columns, are the areas of interest that various stakeholders may have. The publishability of the results, the fundability, the translation, as well as the profitability of the research. What you see along the first column coming down is the variety of stakeholders that are interested in the results of research. First is listed the scientist. Of course, you've got other funders, industry, all the way down to consumers are also very much interested in the results of research. And so if you look just quickly at the graph, you can see that depending on who the consumer or the stakeholder is, their interest in research, whether it be based on the fundability, the translation, the publication, et cetera, does vary across the different groups, but all being important in a collective sense. So this article that was published by Prince in 2011 in Nature Reviews actually highlighted and confirmed some of the concerns that people were considering about the reproducibility of results. Let me orient you a little bit to the slide that was published. What you see here are they looked at 67 projects. They had 23 investigators help them look through 67 projects. They focused in the area of oncology, women's health, and cardiovascular disease. And the majority of them were oncology. That's represented in the orange. What's represented in this middle pie chart are the approaches that they used to reproduce the results, right? And so this is what they were doing. Now you see that this amount right here, which is about 21%, they were able to reproduce the model in-house. You looking at these 67 projects, one-to-one in only 21% of the cases by using what was published in the article and doing a survey. What you also see is 67% is that literature, the model was adapted to the internal needs, and then you see this distribution. So, but a very small percentage of them were actually able to be replicated one-to-one. What they found on the result, which is represented in this final pie chart, is that inconsistencies between what was published and what they were able to reproduce using the internal approach was only evident in about 2/3 of the projects that they reviewed. Only about 20 to 25% were they able to reproduce all the findings or at least the main findings. So again, they're not saying through this article that there was fraud or that they did something terribly wrong. That was not the purpose of this. It was just saying that there can be variations in way studies are conducted, resulting in variable results and inconsistency and inability to reproduce them. And that translates into other issues when we're trying to move data along along the trajectory of research, translating, as the NIH wants, discovery into improved health. We always talk about the fact that the NIH is not the National Institutes of Research. It's not the NIR. It's the National Institutes of Health. And so their focus is on human health. And when you're writing grant applications, you've got to immediately and early in your grant application relate how your work is going to translate either immediately or eventually into improving human health. And that's a very important, know your stakeholders, know that. I think problems that emerged several years ago when Congress was cutting the NIH budget is that they were having a hard time convincing taxpayers who were the, really paid for the NIH, is that all the investment in the NIH was actually making a difference in improving human health. And of course, we know it does, but as scientists, we're always saying, give me more money, because if you give me money, I'm going to cure this or I'm going to cure that. They said, you've been telling us that about cancer for decades, and you're still saying the same thing. But what we forget to add is the advances that we've already made, and now we're making a case that we need to do something even more novel to address a new cancer that has emerged, or a treatment that will improve the quality of life. This example here, which was published as a very interesting study by Perrin and published in Nature in 2014, was one that was looking at what was happening with the mouse models and what was happening in published research. What happened in this particular situation is that there had been a number of animal tests looking at amyotrophic lateral sclerosis, the AML. A number of what they were finding is that all these animal studies had been done. They were translating this into developing new therapeutic interventions, and they were not working in human studies. They weren't working as well as they had been doing in the mouse models. So the ALS Therapy Development Institute actually went forward and repeated these studies and then compared these drugs and these treatments to see how they compared to what was being published. And if you look at this, you can see what's represented in the blue are the change in survival observed in the mouse studies, what was published. Of course, you see much larger horizontal blue lines compared to when they went and looked at the data and they did their studies looking at the exact same drugs. And you can see the results were underwhelming compared to what had been published. Again, bringing into question how reproducible are these results. So everyone agrees, okay, we've got an issue here. We want to address this, and it's important that we are guiding those that we train and those that we work with and collaborate with to focus on these issues so that we can minimize any potential problems that we may be encountering in our research design and our experimental design, and the way we communicate our methods of our studies, so that at the end of the day, we actually do increase the success rate from what we're finding and discovering into meaningful interventions and therapies that can be used to improve human health. Some of the challenges, though, for improving reproducibility are some of the ones that are listed here. Of course, there are others that we can discuss, but let's just talk a moment about these. One, we all know the scenario about publish or perish, right? You've got to get those studies out. You've got to do this. And you've got to, in order to get things published, you have to have innovative ideas and something that other people haven't found. It's a very, very competitive environment out there. How many of you all have felt in a competitive environment by working with a couple of hands, not too many? You just feel that there's some pressure out there about what you're going to do. Are you going to be able to bring something forward? There have been challenges with funding lately, with reduced monies actually to fund all the research that we have. So having really innovative ideas is important. There's a high dependence on high-profile, high-impact publications. And so addressing that puts a lot of pressure on principal investigators and those that they work with to try and get things out, and maybe sooner than perhaps they're ready. The publication practices are also quite interesting. As you all know, it's much easier to get a positive study result published than it is to say, well, we did all of this work and we found nothing. Everyone goes, well, who wants to know about that? The problem with not publishing the negative findings is, what's the key problem? Someone else is going to do the same thing, come up with and they're going to waste time and they're going to waste resources doing it again. Now, maybe they find something, but the chances are they may not find anything, and then it just continues. So over more recent years, editors have gotten much more sympathetic and also directed at accepting well-done studies that show negative findings, if anything, to inform the scientific community that maybe this isn't a path worth wasting your time and your money on, right? Weak training is another area, and it's not meant in a negative way that people are intentionally meaning to be weak, but I don't think that we've been as systematic or have had as clearly defined methods to make sure that the trainees and those who are building their professional careers and research understand about the appropriate experimental design, the true importance of an adequate sample size. I mean, you all have heard about type 1 and type 2 errors, and things like that. Sample size is critically important. Also, randomization and the need for blinding results. It's very difficult to be objective when it's, your baby, your idea that you've created. I mean, it's hard to be objective when you're looking at so blinding results or, and randomizing either samples or individuals to different groups can definitely minimize that bias and help improve not only the transparency, but also the rigor of that design. Also, the last one we'll talk about, but then I'm going to give you some examples in the next slide, are these self-deceptive practices we have in experimentation and analysis. And it's not that we mean to be that way, it's just that you're focused on this hyper competitive environment, the need to publish or perish, and oftentimes, you just kind of lead yourself to believe, I think I see a pattern there. I don't you see it? I think I see a pattern. That's so close to significant. It probably is, and it's just hard to be objective at some cases. So this article actually published some of these things summarized in 2015 in Nature, and it's a little bit of a cartoon, but how scientists fool themselves and how they can stop it. So in the top half of this slide, you can see these 4 types of things that can happen. The first being hypothesis myopia, and that's where you're collecting evidence to support a hypothesis, but not looking for evidence against it. So you only look for things that are going to support what your question is and where you think it's going to go, but anything that might go in the other direction, you just kind of, just don't worry about that, The Texas sharpshooter, this is what we were talking about a little bit earlier, that there's this sort of random pattern that all of a sudden you start to see a beautiful, I don't know, Mona Lisa or a Monet or something out of it, and it's nothing. But you start to conjecture that maybe there's a pattern that's meaningful and might be an interesting finding when in fact there may be nothing there. The asymmetric attention, where if the results of your experiments are different than what you expected, boy, you spend weeks and months going through it, making sure that everything was correctly done, and did you miss something, was there a mistake? But yet if they align with your hypothesis, oh yeah, well, you see, I thought that was right, let's just move on. So it's not having the same attention to the rigor and double checking your results regardless of the findings. I do mostly clinical trials and epidemiological studies. And for every one of our papers, before we move forward with that final version, I always have a second person independently analyze the data. It might be another member of the team, but they have to take it, they run it again, and make sure that we're finding consistent findings. Certainly don't want to be on the front page of a journal article that we had made some flaw. So there are things that you can do to incorporate in your methods to double check your work, whether they're positive or negative. I'd rather find out before it's published. If we made a mistake, a coding error, it happens. It happens. A decimal point falls off, you put one in the wrong place, the tables shift over by 1. So that having that attention, that symmetrical attention, if you will be important. The just so storytelling is another strategy that they listed in this article, which is, where you after the fact and you see an interesting finding and then you create a hypothesis around it. And that's always a little dangerous. That's very dangerous to do that because it's not something you thought a priori. It's not to say that you can't find some interesting findings, might help you generate another hypothesis, but oftentimes people will go around and create a story around a finding rather than the other way around. And that, may be difficult. Some of the de-biasing techniques that they proposed in this article is one is being your own devil's advocate. So explicitly consider the alternative hypothesis and make sure that you have as much attention to exploring that as you did to your original hypothesis or your primary hypothesis. The second is pre-commitment, which is in advance, and usually when you're submitting grants or you're doing any of this, they make you define your methods in advance of even doing your study, right? So you outline what you're going to do, how you're going to include or exclude samples or individuals, what methods you're going to use, how you're going to handle missing data. All those can be defined up front so that you can follow that. Doesn't mean that you may not do sensitivity analyses to say, and we tried an alternate approach and this is what we found, but it'll keep you for fishing for a method that will help you confirm your findings rather than making sure that you're systematic in your approach and staying objective in your findings. The team of rivals, I think this one's interesting. I'm not sure how well this would work, but invite your academic adversaries to collaborate with you on a study. I've heard some strategies that people do that, or I leave that up to you. Blind data analysis. This is another one where you may take, a data set. Maybe it's not the actual or real data set. You blind it, you run the analysis, do the programming, and see what happens with those results. Again, it's sort of a test to make sure that you're staying objective, your study team is staying objective, et cetera. When I have new people that are joining and working in my laboratory, I don't have pets and things like that. I've got computers and surveys and stuff like that, but still a laboratory of sorts. One of the things that we're doing, we've got just test data sets. And people say they know how to run analyses. We'll say, well, we already know the answer, but we'll say, well, go ahead and answer this question, run the analysis on this data set, and let's compare results. That's one way to check someone's skill and competency and perhaps familiarity with how to use these data sets. Sometimes trainees, and some of you are trainees, and sometimes even investigators come in with perhaps maybe a little more confidence than they actually have skills to back it up in that very beginning stage. You want to please the person you're working with, but it's good to test it. Make sure that you're confident, that you're skillful, that you've got what you need. And if you don't, let them know so that you can get the training that you need, so that the next time you go down this pathway, you will have an enlightened view and you will have the skill set to do what you need to do. Now, there are 4 elements of rigor and transparency that the NIH has highlighted. This is all over their website. They've got lots of information on it, and we're going to go through these, in an efficient way. But let's go through them. The first element is the scientific premise of the proposed research. The second is the rigorous experimental design that will lead to robust and unbiased results. The third is consideration of relevant biological variables. And the fourth is authentication of key biological and or chemical resources that you may be using. So let's talk about these. Element 1, the scientific premise. This one really talks about the quality and the strength of the body of evidence that supports your research. You need to consider, as you're doing your literature review, I'd even recommend as you're going through it, make a little table where each of your articles put your strengths and weaknesses. Actually, my team will work on including the study design, the sample size, and just key experimental aspects. Did they use subjective or objective measures, that sort of thing. But consider the strengths and the weaknesses and where those gaps are, both in the research that's already been published, as well as your preliminary research, that you may be doing your preliminary study findings. It's important For many of these new project developments that were not successful, almost always when they went back and they looked at the evidence that they drew from the literature, they realized that the methods that had been published were incomplete. They couldn't tell if they had controls. They had no idea, what some of the key elements of the methods were. And if they had known more of that, they would have been better informed, probably would have asked for a replication type study before they invested a tremendous amount of time, money, and other resources in taking that project to the next level. So the element 2 is rigorous experimental design. This implies that scientific rigor is paramount to your methods and your processes, making sure that you are applying the strictest application of scientific rigor and the method to ensure that you have robust and unbiased results. This comes with, are you choosing the right design, the methodology, what analytic techniques are you using, whether that be initially just to analyze the data, but then next to analyze the composite of your results. And do you have the skills, and does your lab have the skills to actually do those analyses? And then, of course, looking at the interpretation and the reporting of the results. Some of the things that you can do to help improve the experimental design and the scientific rigor are listed on the right-hand side of this slide. And that can include the use of standards, estimating your sample size to make sure that you're going to have a sufficient size to detect a difference and determine the power at which you can detect that difference. Using randomization or blinding where that's appropriate can certainly help make sure that you're controlling for some of these unmeasurable confounders, including appropriate replicates, controlling for inter-operator variability. That's a very important thing, even when from doing lab experiments as well as to doing survey tools. Use of appropriate statistical methods that have been planned in advance and have already been deemed appropriate. Sometimes it's been reported, and this happens in clinical as well as in the basic science, that scientists will use the tools and techniques that they're comfortable with, the ones they know how to use. Several of the authors of these articles that were in the beginning of this presentation highlighted the importance that so many advances have occurred in statistical analysis with how to handle missing data, how to address some of the incompleteness in study data collection. There are a lot of aspects that the old methods really are not good enough anymore. They're not appropriate. So you need to be thinking ahead, make sure, talking with your mentors, make sure that you're talking with colleagues and perhaps people who are a step ahead of you in your research. Look at the robust methods that they're applying and make sure that you're using the correct ones, not just the ones that you're comfortable with. Inclusion and exclusion criteria should be specified up front, not when you're doing the analysis saying, oh, that one doesn't look good. Ooh, I think that's an outlier. Define those up front. It gives consistency in your lab in applying those. How you're going to handle subject retention and attrition, whether those are samples, animals, or humans, and then the handling of missing data. All these things can be done in advance. Now, element 3 is consideration of the relevant biological variables, and these should be factored into the research design, analysis, and reporting, both for humans as well as other vertebrate animals. And the variables that we're talking about, we'll spend more time on sex today, but also age, weight, and size of the animal, any underlying health conditions, and of course there are others, but these are the ones that people are talking the most about. Most recently, and since the landmark article came out from Collins and Janine Clayton in Nature in 2014, is sex as a biological variable, and that's one that we'll talk a little bit more about. What is important about these biological variables is that they need to be included across the continuum of research, from discovery, where we're looking at the basic and the basic research, and then going into turning this discovery into health by looking at your preclinical studies, the translational research, your clinical research, healthcare, and then ultimately what's happening in population health. You're going from the less data that's available at the basic science to having more complete data about how an intervention, a technology will work in humans. So with regards to gender or sex and looking at this, in clinical studies, we've been doing a pretty good job, partly because the NIH, you can't get funded unless you include women, children, and minorities, and if you don't include them, you have to justify it for clinical studies. And you can see from these pie charts here that we're about 50-50, which is about right. That's about what our population is. We're not as good in the animal studies, although we're doing much better. You can see in 1994, 100% of studies did not list the sex or age of the animals when they published their results. Now we're seeing that is down to, a little, 17, 18%. The number of studies that include both sex and age is up from 1994, but it's still under 60%. And that's, not going to be very helpful, and we need to do better across the board. As I mentioned, you need to look across the continuum from basic to clinical science. It's very important that you review the literature and look for reported sex differences or lack of sex differences. You use this in the justification for your inclusion or your exclusion of sex as a biological variable in your studies. There have been studies where they have clearly shown the disease affects women and females. And when you go back to the preclinical studies, they didn't list it, but when you go back and call the authors, they did, all the models that were developed to test the interventions were done on male mice. Really? That's a problem. And we wonder why the models don't translate into therapies that would have a higher success rate. The experimental design really should consider the inclusion of sex and the number of subjects to be able to at least report out. You might not be looking at differences, but at least report how the effect of the intervention or the compound works in females and males. The 4 C's of studying sex to strengthen science are listed here by the primarily supported by the Office of Research in Women's Health, which is the first C is consider, make sure you're thinking about sex as a biological variable, then make sure you collect the data. You're going to analyze it and thereby characterize the impact of sex as a biological variable on the science that you're investigating, and then lastly, communicate those findings. Make sure that you're reporting them out. It can be an aggregate, but also reporting out what happens in males versus females, men versus women. So you can develop the data analysis prospectively to make sure that you are considering this, that you're reporting whether there are or are not differences, and that's okay too. That's important to know. If there are no differences and you don't have to worry about tailoring treatment to men versus women, that's good to know. But where you do need to tailor it, we need to know so that we can improve the health of people. If you are not going to include sex as a biological variable, and you're not going to include either, male and female mice or male and female tissues or men and women in studies, you've got to be able to provide a strong justification for it. Acutely scarce resources is one thing that people are saying for the animal studies, but I'm not sure how much longer that's going to fly. But sex-specific conditions, so if you're studying prostate cancer, you don't need equal numbers of women. Let's, that's in this case, especially if you're looking at, chromosome-based conditions and not the way people describe themselves. Research where a study of one sex is scientifically appropriate and justified is another one as well. Okay, the element 4 is authentication of key resources, and that's the key biological and chemical resources or those that may differ from lab to lab or may differ over time. In reading some of the materials and preparing for this, I've done a little bit of basic science research, but I said most of mine is clinical and epidemiological and population health. But to hear the things about some of the people are keeping samples for a very long time. How do you know that they don't deteriorate over time? You have buffers or other things that perhaps have been around or some of your chemical components, and maybe they have deteriorated or they've become contaminated. It's important to know. They can influence the results and they are integral to your proposed research. It's very important for the authentication that the researchers ensure that the resources are working, that they have expected properties and that they're valid. And so some of the things that you may want to consider about the key resources, and this would be cell lines, chemicals, antibodies, or other biologics. Here, they just list some examples of what can happen with bad antibodies and some things that can happen. There can be cross-reactivity, variability, can even be the wrong application in use of this. So keep these things in mind as you're working in your basic science research, because these have incredibly important implications for the next phase of research. And of course, in dealing with cell lines, there's articles that talk about the fact that they may have been mislabeled, they're misnamed, they could have been contaminated, and these things can have important implications in the next phases. So for the NIH to make sure that people are doing this, and of course they do say this is not new. We've always expected that you were doing this, but now we've provided greater clarification, very specific instructions on where we want to see it, and holding you accountable to the fact that you're including it. So for the scientific premise, scientific rigor, and consideration of sex and other biological variables, all of these would be in the research strategy section of your application. Specifically, the scientific premise should be highlighted in the significance section. The scientific rigor, as well as the biological variables, both need to be well described in the approach. You can see that the authentication of key biological variables, it's a new attachment, and it's included with the application, but it's not embedded in the research strategy. Important to know that for review consideration and for scoring and the overall impact, the first three all factor in. And they'll ask at the end, sex is a biological variable, because before the reviewers will score the application. The authentication of key biological variables, however, is not included in the scoring and the weighting of the overall. Okay, so now we're going to watch.
Do you mind if I ask a question?
Yes.
Maybe I missed the nuance. Study designs. Is there a school of thought where scientists, researchers feel they should, for instance, study for training on something? Is it necessary to actually assessing the skill?
I think it depends highly on what the ultimate purpose of the training is and what type of research they're ultimately going to do. Many, and I remember when I was early in my career, they would say, oh, we never wanted to deal with those female animals. They just had too many problems. You had problems with the males and the females. It was just a disaster. It's like, middle school, dealing with men. So it was just a lot of problems with doing that. And so it was just easier to deal with male mice. If you're trying to train someone who's going to have to handle the dynamics of dealing with sex differences in male females, then to exclude them would not be, they would never get that type of training to understand how to balance between the two, right? So that's just something to think about. If you're focused completely on male-oriented diseases or female-oriented diseases, then perhaps looking at the alternate is not going to be as useful. I hope that that's helpful. Okay. Yes.
Throw a wrench in there. A female gerbil does have a prostate.
Well, there you go. Okay. Well, and I understand that. What is it? Turtles, when they reach a warm enough temperature, they turn into females. Is that right?
Eggs.
Yeah, so just saying. I mean, so you just never know. So there are things that you have to be aware of, and sometimes by not including this in training, you're disservicing, providing a disservice, if you will, to future research by not understanding the dynamics of dealing with it. So let's go forward and we'll look at this little video.
Don't get it. I do not get this.
Hey, what's up? You don't look too happy.
I'm not. I don't understand this at all.
What's going on?
We've been trying for months to replicate those results from the Hansen lab, but ours still don't match up.
Okay. You know what? I'm going to go give him a call. See if there's something in the paper, maybe in or left out of the methods section for that assay that we're missing.
Okay, great.
Yes, several times over the past few months. I'm just brainstorming here, but is it possible we're missing something? Maybe there are some differences in the solutions or peptide?
No, I'm looking at what you sent me, and it looks like you've got the formulations exactly right. Listen, why don't I send you the files I have? It's all the raw data and the protocols. Maybe you find something there.
Oh, great. That's incredibly generous.
Well, I'll tell you what, this is starting to bother me too. Will you be in touch?
Absolutely. Thanks so much, Jeffrey.
You got it.
Will you run it one more time while I look through his files?
Sure. I hate to seem superstitious, but cross your fingers, will ya?
Well, that's not entirely scientific. Whatever works.
Oh, I can't believe this. It's still not working.
Really?
Really. I'm super frustrated. Why can't I repeat this? I've gone over and over the method section of this paper. Every single thing that's here.
Doesn't make any sense.
This is all I think about. I am counting tubes to fall asleep at night.
No, that's just sad.
But true.
I'm going to schedule a Skype call with Jeff Hansen. I've looked through the protocols and data, and I might have something. Don't get your hopes up. Face to face, maybe we'll get somewhere.
Good idea.
No, it looks like you're following all the protocols.
What about the controls? I didn't see anything in your paper or the files about how they were prepared.
We use the same controls we always use.
Where do you get them?
I mean, we keep them in the -80 freezer and we take them in and out as we need them.
So these are control samples that have been around for possibly years.
Yeah,
I've been preparing them fresh each time.
That could be it.
sure could. Things taken in and out of the freezer will degrade over time.
Like ice cream. It's not going to taste as good if you've been taking it in and out of the freezer for months, right?
Oh,
That tiny detail.
Could make a huge difference.
Of course.
Listen, this has got me thinking. We will rerun the experiment here using freshly prepared controls. If you'll do the same once more, then we can compare results. I'm a bit worried about this, and I want a result. Experiment.
That sounds like a good plan. Let's discuss our results next week.
Got it.
and I can go back to counting sheep.
Hey, how many of you all are basic scientists? And those who do clinical science probably have gone into something similar if you're trying to repeat results, you're trying to test something in the clinical world, a lot of times in clinical trials as well. Have you ever experienced anything like this where you've gone in, you looked at the paper, it's like, a neighbor giving you a recipe and they leave out the one ingredient that makes it good? That happens a lot. Maybe not you. I don't do a lot of baking, but, had a few disasters. So what happens to you? What do you think about this case? Do you think they handled it correctly?
Yes.
Ever heard of things like this happening? Do you think that the reaction of the senior guy that they contacted, the senior investigator, was what you would expect that everyone would do?
No.
No. Especially sending over all the files, huh?
Yeah.
Right. Is it the right thing to do?
Yeah.
It is. But it doesn't always happen. But you can see a person in the lab, whether they're a trainee or a collaborator or some of the research staff, working with their mentor, staying actively involved, connecting with the people. Now, I will say in many cases in clinical research, I'll call the lead author of a paper at the drop of a hat if something isn't working, or I need access to the survey questionnaire, or I need access to their methods. And people have been quite generous. They're always, you always lead out with, I read your paper with such incredible interest. Congratulations on your publication. I need your help. And ask questions like that. It always helps get that door open just wide enough for you to get in and then ask the questions. Have you all used that technique when you couldn't find anything, reaching out and asking? In many cases, has it worked for you? At least they provide you something?
Well, it wasn't exactly the same situation, but we did reach out to them, and they kind of just summarized their results to us. That was sort of their response. And we were like, no, but we're having an issue with this. And they were like, yeah, this is kind of what we found in the study. And it was sort of like, okay. We went back and forth a couple times, then we gave up. But it was just it was also a small thing. It wasn't, we weren't pouring funds into it or anything. But it was really just a literature review. But
A literature review, well, and that could happen and people worry about it, but you can see the types of things you have to think about. Certainly when, we were taught clinically that when you hear hoofbeats, think horses, not zebras. So you start with the horses of things that would be normally occurring and things you think might be off. And then you've got to think beyond that if you're still not coming up with something. They finally decided to ask about the conditions around the controls. The same thing can happen in clinical studies. Did you do anything different with your control group? Did you have attention control? Were they really control, or, was there something else going on? So, do make an effort to reproduce results, test your own within your own lab, whether that's clinical or basic, to see if you can replicate them as well and make sure that your systems and mechanisms are solid. Always recommend you have someone other than you and the person who did the primary analysis to check the data. And then if you're not finding things, and this is an important, do reach out. If you as a more junior person are not able to reach or get through to the senior person, have your mentor, your department chair, or someone of that equivalent stature reach out, and they may be more successful in getting to that answer to help you get to the next level. I think the editors of journals, and it started out with 30 editors from scientific journals. Bruce Alberts, I was on the NIH Science Center for Scientific Review panel when he was on it, and all of this was starting to unfold. They got together and said, we've got to do something as editors of these top tier journals to push this, not accept papers unless they're giving us complete information. Nature now has a checklist. You've got to answer all these questions. Even without a checklist, I urge each and every one of you to have your own checklist on your methods to make sure that you've done it right, so that you feel good about what you're putting forward, and that will help you write better papers and to do better going forward on that. Any other comments or questions about this video? We have one more. So this one, we're going to talk about sample size outliers and exclusion criteria. I want you to know all this stuff is, if you just type in NIH rigor and reproducibility, they've got 4 modules on each one of these. You can go watch them. You can see they're short, but they also give some interesting strategies if you watch the dynamics on how to handle things. And perhaps you don't experience it when you reach out to investigators, but hopefully you will mirror the positive when the issue comes to you.
I performed the experiment exactly as Donna described in her protocol, and compared with her results, mine just aren't matching up. I just can't get the results to be statistically significant.
Well, something may be wrong with the way you're doing it then.
I guess.
This was the 4th protocol that Donna perfected when she was postdocing here in the lab. I mean, this is a good study design. I really don't get why you can't reproduce it either.
I'm following everything to the T exactly as described. It's just so weird that it won't work.
Let me ask you this. How many samples did you use?
I used 8 mice per group.
Let's try this. Add 2 more mice to each group. Then try a different statistical method. If I remember correctly, I believe Donna performed a 2-way ANOVA. See if changing those parameters gets you the results we're looking for here.
That's a good idea. Remember, Robin, toss out anything greater than 10. The normal range for living cells is 3 to 7, so anything higher than that is probably due to cell death. So keep that in mind. It could make a difference.
Okay. Thanks, Jamal.
Let me know how you do, okay?
Of course, Dr. Fielding.
Please call me Harry.
Dr. Fielding.
Hey, she's new. You did the same thing.
No, I didn't.
Yes, you did.
Oh, come on.
So, where are we here?
I did what you said, and I added the 2 mice per group. And look, it's still not statistically significant. These results are inconclusive, and they don't match with Donna's results at all.
And you varied the statistical test? Ran a 2-way ANOVA this time?
Yes. I mean, why is this happening?
Robin, I've been watching you a little bit in the lab here, and I hate to say this, but it seems like you're struggling a bit.
What?
Sometimes students come in here and just can't hack it in grad school.
It's just embarrassing that I can't repeat this test.
Well, I'm worried too. We do consistently high quality work here, Robin. We just can't afford to lower our standards like this.
I'm sorry, Dr. Fielding. Here he comes. But I don't get another lecture.
You're okay. Okay.
Jamal and Robin, do you have a second?
Of course.
Sure.
Well, I think you both know that I've been concerned about Robin's work and that experiment not being reproducible. So I decided to take a look at Donna's old lab notebook. Took a while to decode, but I think it was worth it. I found something.
Really?
First, I found that some samples were excluded from the experiment, but there's no explanation as to why. There's no justification for leaving these out, and no criteria for outliers or excluding samples appears anywhere either.
I wonder why.
So if she'd included those samples in the analysis, what would it have looked like? Is it similar to what we were looking at before, or is it more like Robin's results?
More like Robin's.
Wow. Really?
And there's more. As I was digging further into the notes, I realized that all of the outliers were actually samples from female mice.
That's so strange.
And significant. Rigorous research, which, by the way, Robin, you were doing, requires considering sex as a biological variable when using mice, or any animal samples. I was the one who was not doing a very good job, and I should have caught that.
That's okay.
No, it isn't. I never even thought to tell you which sex to choose when I told you to add those 2 mice samples.
Well, I didn't think of it either.
Yeah, but I'm the PI. I'm supposed to train you in designing and conducting experiments. And I changed the design of the study halfway through. I had no business doing that. So what I'm thinking is I should take my own medicine, so to speak, and get back to a more carefully designed study. More consistent and, most importantly, much more robust. I think we should stop, regroup, and start over. I'll need you on this too, Jamal. We need to discuss the best way to do this.
Great.
So I'll see you at 3 to discuss.
I'm good.
Me too. I'm in. Thanks so much, Dr. Fielding.
Please call me Harry.
Okay, I'll try. Harry.
I'll see you at 3, Dr. Fielding.
Yes.
What?
Standing acting, I know. Initial thoughts about this video. Have you seen this happen before? Or parts of it anyway?
Yeah.
The first part, yeah, where people get blamed for things, and it's just it hasn't been attention. What do you think are some of the key things that led, eventually to them coming to the right next approach of what needed to be done? What was important, an important thing that you would need to do as an investigator as well? Yes.
Question past results of your own lab, which I think a lot of people are really cool doing, and it's definitely not a knee-jerk reaction. You got to really push somebody to question their own or results of someone they trust.
Because they're trying to build. They figure that pillar's that foundation's down. Now we're going to the next level. But I think that's an important aspect. Yes, that's critical. What else did y'all see in this, or did you pick up?
Was there note taking? So if she didn't do any of the note taking, they wouldn't be able to figure it out. So making sure that whatever you're excluding, including new stuff, whatever notes and everything.
How many of y'all keep a lab book to the decisions? And so not everyone. For those who aren't doing it, are you doing clinical work? You're just not doing the other, or you're not involved in that? You're lucky that way, because most of it is in code. I do a lot of health research as well. Whenever we started major projects, I'm more seasoned than you, but I still kept a notebook of the discussions that we would have had in lab meetings, and help me go back at the end and determine, because you can forget what you've discussed. So the code is important, but those other discussions that come that help you define where you're going can also be helpful and may help you decipher things as you get further down the road later. Keeping that book, keeping that binder, whether it's an electronic or a paper binder, is important. Most of the basic scientists are accustomed to keeping a lab notebook, and those are really important. It's also important to go over those with your mentors, even your data code, your coding for your analysis that you're going to be doing. go over those and make sure. I certainly in my career have seen mistakes made. They're subtle. And I mean, it completely changes the results and the interpretation and the findings. So it's very important to do that as well. Those were some tough conversations that they were having, right? It's almost hard to believe that the doctoral trainee didn't just walk out and say, I'm done. I mean, you essentially said, I'm no good and that sort of thing. And that's tough. What thoughts do you have about that or strategies to deal with that?
I have a side note. So I thought it was really helpful that her partner or whatever, Jamal, he was very supportive and also gave his own ideas, because I hear that these labs and stuff can be competitive. So instead of him just being oh, she's messing up, he wants to look good. He was actually assisting her, trying to be involved. So I thought that was good.
That is good. You're absolutely right. And you hope that you will be the same type of a team player. We're all going to run into challenges with our research. And so if you can, have a group that you can talk honestly about your research and get that feedback, and that they're going to be trustworthy, you will be trustworthy, then you can build some camaraderie for this double checking of what you're doing. Other thoughts about this one? Yes?
It's also, it's also possible that she could have done that investigation the PI did. She might say, I'm interested in seeing Donna's data and how Donna did it, and curious if maybe there is a discrepancy. It's hard to, if you really have, or a hawk of an advisor that isn't okay with, or that is coming bearing down on you as a grad student, that might not necessarily be possible, but some PIs would be amenable to that. They're okay, so you want to do an investigation as to maybe you think that there was something in Donna's work that you didn't read in the protocol somewhere,
Well, that's true. And I think you alluded to this, but how you approach the PI on doing that, it's so important, right? Not as an accusatory, but they probably didn't do it right. And but just say, listen, maybe we can learn something by going over this. Would you mind going over? We can go over it together, or I'd be happy to take a look at it first. Yeah. And then, flag some areas where I have questions. But it's incredibly important, especially at your early stages, but even at the later stages of your career, to get that right and to get into the right habits of questioning appropriately, asking the questions, double checking your work, reviewing what the lab has already done, and are you really on the firm foundation that you thought? And realizing that earlier years, 1994 was not that long ago, where no one was reporting, they weren't even capturing the sex, the age, the weight of the animals. They just got them in and did the experiments and reported out the results. So there may be critical things missing out of the lab notebooks, that would have been very helpful and might explain some of the variability. Ultimately, like I said, we want to lead to success.
Is it appropriate as a junior member of the lab to look at the original lab notebooks? Something?
Yeah, might not be.
That's it's very important how you would approach it.
Okay.
So after you've done this 3 or 4 times, nothing is clicking. You're doing analyses, you're repeating analyses that people have done on large data sets, and you're not getting the same findings. It would be, I would think, I wouldn't mind it as a PI if a person came and said, listen, do you mind? Maybe we could sit down together and look at it. Maybe I'm missing something. Maybe there's something we'd see in the pattern. But it's all in how you go about doing it. If you say, I want to see the notebooks because I suspect there's an error there and you just didn't catch it and I'm here, that's going to be a tough sell, and you probably will not come anywhere near those lab notebooks, right? And of course, those contain very important information, so nothing can be spilled on them. They can't go missing from the lab, nothing like that. So to offer to do it either in an open or say, look, I can come in and just take a look, we can discuss them. Does that make sense? I don't think anyone's going to say, sure, come in, I'm handing them all over to you. I wouldn't do that. I wouldn't do that with any of my things, because what if something happened and then you lost everything and you wouldn't have it? But there may be an opportunity to do it. Other thoughts or questions about that? Let's see. We're right at the end. So I want to make sure you all are aware there's a tremendous amount of information. The NIH has put up more training modules, more resource guides, more direction and opportunities to look at this than I have ever seen them do since I have been an investigator. I would give you the website links, but that wouldn't help you. Just go to Google, type it in, anything you want to know. NIH Rigor and Reproducibility Resource Guide. The Office of Research on Women's Health has a great website. They've got all the information there. The training modules and more videos for you to see are great. Even the modules that the NIH uses to train their project officers. And it explains why they're looking at it and what you should be looking at on the applications that are submitted. Well, you're the one submitting them. You would do well while you have a little more time. Go listen to them and you'll know what they're training them to look for. And you'll become better informed and understand why they're doing it. So there's a tremendous amount of information. I just came back from NIH from a meeting and the director of the Office of Research on Women's Health gave a wonderful presentation, and there was a whole panel session on sex as a biological variable. The basic scientists are still really struggling with this and how to do it and how to afford to do it. NIH gave some very clear messages. One, they say you don't say that you don't have enough money, ask for the money that you need. Ask for it. And if you need more than what's budgeted, it takes a letter. And when you tell them that you need it because you're trying to determine sex as a biological variable, and this is a priority for them, the chances are they're going to tell you no are probably pretty low. Not only that, they have resources through the Office of the Research on Women's Health to supplement grants and give that money to make sure they're looking at sex as a biological variable. So I wouldn't use that excuse if you think it's going to be important. Many of my Birch scholars have started to ask the sex-specific questions. It is giving them innovative publications and innovative grant applications because a lot of people haven't been looking at it quite yet. There will be an entire resource guide coming out next summer from the NIH on a pilot-based program, on a pilot-based approach on sex as a biological variable to help give investigators more information on how to do it and how to do it well. So stay tuned and just stay aware of these resources that can help you. Fit these in at the end of the day if you need to, just to kind of educate yourself and get as up to speed as you can about these very key areas that will help improve the quality of your research, not just the quantity, and lead you to more investigations and discoveries that actually truly will lead to improved health. So thank you for your attention. It's been a pleasure.
Thank you so much. So this is our last class, and we have a very brief box vote survey that we would like you all to take. Tim's going to come in here. The questions are going to come up. And it really is just about the logistics and the substance of the class. We would like to improve it and change it to the extent that we can to make it better every year. So we really value your opinion. It's only going to take a couple minutes. The sign-in sheet's going to go around, and we're going to ask you just to answer a few anonymous box vote questions for us. If there are things that you would like to discuss with us individually about the class, please feel free to call us. 988-1147 is our phone number. I have business cards by the front door. Please feel free to take those. Email us and let us know what you thought about the class and how we can make it better. So your PIN number for Uptown, I know you can't see the screen, 99802 is the PIN number for box vote. Here is our first question. Is Thursday a good day for this class based on your schedule? And if the answer is no, what day is better? Okay, so looks like maybe we should move on. Everybody voted. Number 2, was 3 o'clock a good time of day for this class based on your schedule? And if not, what time of day would have been better for you? Okay, let's move on. Is downtown or uptown a better location? As you know, we have it live downtown and we broadcast it, but that doesn't necessarily have to be the case. We could do it in reverse order, so we're just curious which location is better for you all. Number 4. What topics would you like to see added to the series? Anything that we didn't talk about that you would like to have learned about that you thought would have been important for your career, for the research that you're going to do? We're going to ask you in a few minutes about the topics we did present. So right now we're just asking you about anything that you would like to add, anything that there wasn't a presentation on that you thought would have been helpful.
And I'll say that some of the things we presented on this year answers in the past.
Absolutely.
That's
Okay, good.
Grant.
How'd you get money so you can do research? Very important. Okay, moving on to 5. What topics that were covered in the class were most relevant for you, for the type of work that you're doing now, for the type of work you want to do and think you're going to do? We're going to ask the reverse in a minute. So this is what was most relevant for you. Our next question, what topics were the least relevant to you, if any?
Nice.
Move on to 7, please. This is an open-ended question. We are open to your suggestions. How could we make this seminar series better? We put it on every fall, and we cover some of the same basic topics, but each year we do change up some of the topics. We change up how we do things. We've added box vote in the last couple of years, and we're just interested in what would make this a better seminar series for you and for your peers, for the folks who are sitting in your chairs this time next year. What could we do differently? I'll have to ask to put those in the budget.
Two people.
So this must be the time after lunch when we start to get hungry.
3 to 4.
Yeah. Moving on to 8, please. Oh, that was the last question.
Great.
All right. So again, if there are things that you would like to talk to us about that you didn't put in box vote or didn't feel comfortable putting in box vote, please feel free to reach out to us, email us, call us, come by and see us. We have business cards by the front door. Thank you all very much for attending. I hope you enjoyed it.
I'll export these and send you the results.
Hey, Tim.
Is there available
Next week.
Yeah.
For me to come in?
Sure.
Tuesday, Wednesday, or Thursday?
Anytime. It's
Okay,
fine.
maybe
Yeah.
I'll respond to that email.
Yeah, that's fine. Sure.
Thank you. Okay.
great job getting through this.
Sure. It's just, I know it's your turnout.